Alright, in this video we are going to be talking about multiplying fractions. In previous videos we've already talked about what it means to add fractions together, to subtract fractions, comparing fractions, even what fractions are. And since we've kind of defined fractions as just being other numbers on the number line, we'll see that multiplying fractions is no different than multiplying integers. So when we say multiplying integers, we mean a times b. Well, that's just b added to itself a times. A is the coefficient, and it tells us how many times to add b to itself. So with a fraction, there's no different. If we have a times m over n, that means m over n added to itself a times. So look at an example. If we have 2/3, well the denominator says, hey, let's divide the length of 1 on our number line, right, by 3 equal segments. 1, 2, 3, 1, 2, 3, 1, 2, 3. And 2/3 means the length of 2 of them. Well, if we then add another 2/3, then how many thirds do we have total? We have 1, 2, 3, 4 thirds total. So the answer is 4 thirds. If we had 3 times 2/3, that would mean that we had 6 thirds, right? 2, 4, 6 thirds. And in general, whatever that coefficient is, when we have, say 3 times 2/3, we really can just multiply 3 by the numerator because our denominator is always the same. 2/3 and 2/3 and 2/3, well, we're still talking about thirds even in the answer. The denominator never changes. However, instead of having 2/3, we now have 1, 2, 3, 4, 5, 6 thirds. So we could do some problems and say, well, how many halves do we have here? Well, we have 3 halves 4 times. Well, that's a total of 12 halves. A good example here to kind of bring this point home of multiplying fractions is no different than integers. 2 over 1 is 2. So if I asked you what's 3 times 2, you would say 6. And if I asked you what's 3 times 2 over 1, then that means 3 segments of 2 when the distance of 1 is 1 segment. Well, that's 1, 2, 3, 4, 5, 6 over 1, which is 6. Now, when we talk about having a fraction as a coefficient, nothing's different, but this does get a little bit more complicated to just visualize. And since I think visualizing it is the hardest thing, we're going to use what's called a geometric proof, or a visual proof. We need to talk about what a unit square is. A unit square is a square whose sides are 1. And since the area of a square is its length times its width, then that means the area is 1 times 1, or also 1. And this makes multiplying and understanding multiplication problems kind of easy, because each unit square represents 1. So if I asked you what's 2 times 4, you would say, well, it's 4 unit squares 2 times. And that comes up to 1, 2, 3, 4, 5, 6, 7, 8. Well, now if I said, what's 1/2 times 1/3? Well, you would say, okay, well, that's the area of a rectangle whose width is 1/2 and whose length is 1/3. All right, well, let's take a look at this. If its length is 1/2, then that means 2 of them on top of each other would be a unit square's side of 1. And if its width is 1/3, then that means that 3 of them are going to equal 1. So we've now created a unit square. And we've divided it into how many equal segments? Well, 6. And the area in question, 1/2 times 1/3, is this area right here. So this area is 1 out of 6. And that proves that the answer to 1/2 times 1/3 is in fact 1/6. And you may already notice that all that we've really done here is we've multiplied our denominators and gotten 6. And we've multiplied our numerators and gotten 1. So let's take a look at that on a number line. It's the same concept. If we add 2/3 times 4/5, well, what is our term? Our term is 4/5. Well, let's look at that on a number line. This is 1. This would be 2. This is 0. And you can see clearly the distance from 0 to 1 has been divided into 1, 2, 3, 4, 5 equal segments. And our drawing here, we're representing the length of 4 of those segments. So this point on the number line is clearly 4/5. And now if our coefficient were 2 or 3, we would be adding this distance to itself that many times. But our coefficient is actually a number less than 1. So our answer, we're looking for something that is going to be less than 1/4. Well, exactly how much less? Well, 2/3 of it. So we need to take each one of these segments, each one of these fifths, and divide it into 3 equal parts. which is what we've done here, right? This is 1/5, and we've now subdivided it into 1, 2, 3 parts. So just like we divided 1 into 5 equal segments here, we're now dividing each fifth into 3 equal segments. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And we're saying out of each one of those 3 segments, we're talking about 2 of them. So 1, 2, 3, 4, 5, 6, 7, 8. So in total here, we are talking about 8 segments. And I hope that it's a little intuitive why it's 8, that 2 times 4 is 8, multiplying our 2 numerators. We're saying out of these 4 segments, we're going to have 2 of these little segments. So that's 2 4 times, or 8. And now that's 8 segments. How long is each segment? Well, if we've taken each fifth and then broken it into 3s, we have 1, 2, 3, 4, 5 groups of 3. Well, what is 5 groups of 3? Oh, that's 15. So the answer to 2/3 times 4/5 is 8 over 15. We just multiplied our numerators by our denominators. Let's look at one more geometric proof. If I asked you, what is 2/3 times 3/5? Well, if this length here is 2/3 and this width here is 3/5, then we would need one more of these rectangles so that this entire distance is 1, right? 1/3, 2/3, and then 3/3, or 1. And if this width is 3/5, well, 1, 2, 3, we would need 2, 4 to have 5/5, so that this is 1. So now this larger square is a unit square, or 1. And the question is, how many segments are we now dividing that unit square into? Well, 5, 10, 15. We're dividing it into 15 segments. So our unit 1, has been subdivided into 15 segments. And now, how many of them make up the area of this square, rectangle I should say, whose length is 2/3 and width is 3/5? Well, there's 6 of them. 1, 2, 3, 4, 5, 6. So 6 of those 15 segments is 2/3 times 3/5. And this is what multiplication of fractions mean. The term is still what's being added to itself, and the coefficient is still how many times. The only part that sometimes can get hairy is if that coefficient's less than 1, then the answer is actually saying, what is 2/3 of 3/5? And in this case, it's 6/15. So anyways, I hope this helps, and thank you so much.